Good morning, Ian. Hello, good morning. Can you hear me? Perfect, thank you. We'll wait a few minutes just to see if other people join us, and then we'll get started.
Can you hear me yet? There it is.
Yes, yes.
I love Zoom. It feels like a different microphone setting works every time. Yeah,
Okay.
with a keynote happening at the same time, we'll see if anyone shows up or if they're just gonna
Correct,
rely on it.
correct. Well, this thing with the time at different places is not easy, not to coordinate, but we'll do our best. So where are you physically?
I am in Massachusetts in the
Okay.
United States. Yep.
So right now I'm in Ottawa, in Canada. So do we
Okay.
have the same time?
I don't know. It
No.
is about 9 a.m. for me.
Okay, okay. So that's same time. So
Okay.
we are okay. So are you familiar with Luhmann's social systems theory?
No, I am not.
No.
I
Okay.
started looking through a couple of your um, weekly newsletter things, but I
Yes.
didn't get very far before the conference started.
So where is your area of work?
I'm I'm a systems engineer. I am not an academic, not related to social capital. I'm more of a social capital enthusiast, but the more that I see,
Okay, I remember
um,
now. I read about your bio.
yeah, so
Yes,
the
yes.
more that I see measurements and talk of like how do we associate these things, how do we align these things, um, my specialty is in model-based systems engineering, and I feel like I have something to offer there, but I am an amateur at best when it comes to these things. So
No, but I
your
think
concept of uh, the system model and everything intrigues me. I want to learn more. Um, so I'll let you take over. I don't know if you want a very clean recording for anyone else who watches this later,
yes,
or if you want it
correct.
to be a
That that
conversation. All right,
that that's what I'm doing to share it with other colleagues.
great.
But
I'll stop talking and let you go.
yeah, so your area is very very interesting because uh, see my PhD is in optimization algorithms. I work with genetic algorithms and taboo search and
Yep.
combinatorial optimization problems.
Yep.
So I'm not a sociologist. So yeah, but when we developed this technology, we had to learn. It was a team where we had sociologists and psychologists and engineers and people specialized in database, and so it's been many many years working on this. But right now we have a product that is a commercial product. But I think you quickly understand what it is about, and it's very attractive. I mean, it's a combinatorial problem, so uh, just to develop algorithms to solve it is just something extremely interesting. Have you worked with these type of problems?
Not this type of problem, but I've done like evolutionary optimization, genetic mutation,
Excellent,
that kind of thing. Um,
excellent.
with that kind of optimization. It's been a couple of years, but
Yes.
I'm familiar with that at least.
Okay, so we'll see some of that in my presentation. I will just give a, it's not really a presentation, it's more a conversation, right? What I was trying is to find out who in this type of conference would be, working or interested in working the social cohesion and social capital area together with Luhmann systems theory, which is a little bit strange because these are two fields that they don't, in the literature, they don't appear together for reasons that are very clear reasons. But we developed a technology where we make this systems theory accessible to anyone wanting to use it because it's very abstract. Luhmann's theory is known to be extremely abstract, which means to me extremely powerful, because the more abstract, the more powerful it is. But the problem being that not many people, including sociologists, dare to work with Luhmann because of, how abstract it is. Especially in North America, it's a lot more popular in Europe, of course, in Germany, but in Latin America, it's also, many of his texts has been translated to Spanish, so we have access to, I would say, a good amount of his, uh, intellectual production. But to me, it's fascinating. Once you combine this with governance, which is with what we've done, you develop then a system to analyze society as a whole. Like you see here in this slide where I have the quote from Luhmann. This is maybe his most famous quote: "Communication alone communicates." In other words, people don't communicate. Communication communicates. And this is very counterintuitive because people just don't accept that. What do you mean? We are talking about sociology. How's that people don't communicate? No, because in this systems theory, and I'm started going into the conversation. So anytime you want to interrupt me, please do it. Like I said, it's more a conversation, and if people join, fine. If not, then we spend here some time just talking about this. So I was saying that communication then uh, is the unit in this type of system. But remember, or we have to remember that it's not the traditional open system. It's a closed system, operationally closed system, a self-referential system. All this is terminology, purely Luhmann terminology, autopoiesis. So to get to understand Luhmann, you have to spend some time in terminology, concepts. But once you grasp the basic, then you find it fascinating because, like we've shown here, we are able to analyze society as a whole. Uh, and then we did something very innovative. We used the Platonic solids, specifically the icosahedron, which is the one I have here in the slide. It's perfect symmetry. I mean, it's something that adapts exactly to what we need. 12 vertices. Then you have you locate the different social systems defined by Luhmann in each one of the vertices, and then any permutation is a description of society. So how many descriptions of society you have? 12 factorial. So far, so good.
So far, so good. I am listening, but I've got a lot
Excellent.
to learn, and don't have a lot to interrupt with so far. So,
Yeah. No,
but yeah, I am here.
yeah, but my interest in having this conversation with you is because I try to discuss this with people in the systems area, in the technological area, because we are hoping to have a stronger presence in the market. We do have a presence in the market, but I think we have the potential. We're now developing a patent with this, and I think it has the potential for many other people to participate if we make this an open exercise. So as I was saying, uh, we are able to analyze society in such a way that I do not believe there is any other mechanism to do it. Like I've done my due diligence, doing research to see, is there something that we could compare that would allow me to analyze society as a whole, not just the economy, not just the political situation of a country, but if I have, for example, the permutation of the uh, society of the United States, which is a permutation among 12 factorial permutations, well, I could compare it with the permutation that describes Canada and then see what is the difference of these two modern societies, because Luhmann talks about societies functionally differentiated. So he talks about modern societies, because societies that are not modern, they are not functionally differentiated. So you cannot talk about economics, politics, law, science being functionally differentiated if you are not talking about of a modern, advanced, sophisticated society. So the concept is that each one of these systems is independent, but at the same time interacts with the other ones. But they self-reproduce, autopoiesis, which again is a term that Luhmann borrowed from biology, but now is being very, very well established in sociology. But it's different when you say autopoiesis in biology or autopoiesis in sociology. So again, this is the starting point where we say we have the icosahedron, we have the 12 social systems. Any relocation of any systems is a different permutation. The problem being, what is the optimum society? It's an optimization problem. Now, to optimize it, we use the quadratic assignment problem. Have you heard of that problem? Are you familiar with that problem?
Not really, no.
Okay, so that's it's an NP-hard problem. Um, One of the mathematical problem of the millennium is exactly that, the NP, non-polynomial, non-deterministic polynomial problems. And these type of problems do not have an exact solution. That's why you have to use sophisticated evolutionary algorithms to solve them. And if you solve it exactly, if you find the exact solution, well, you get $1 million. They offer that. I don't think there is an possible to find an exact solution for. Well, there are techniques up to, I think today up to 20 factorial, 25 factorial, but when you go to higher instances than that, this is not just, there is no exact solution. So we have an algorithm that we've developed since more than 20 years ago, that we are able to solve 120 factorial problems. This is something extremely difficult to find software algorithms capable of solving that type of problems. Why 120 factorial? Well, because each one of the subsystems, of the systems, we divide into subsystems, 10 subsystems. So now you have 12 by 10, 120. So now the problem becomes 120 factorial to find the optimum permutation. Now you would say, well, but where would you fit in the geometry? Because the icosahedron just doesn't have the space. Okay, so that's where the model comes about, because we then work on that. We stay under the social systems concept, autopoiesis, reproducing communication systems. All this is in Luhmann's work. This is the very, very famous work from 1984, published in Germany and translated in 1995 in English. And there is a translation, which is the most referenced one. To me, it is the best one, really. There are many translations, but that one is the Luhmann 1995, I think is the best one. I agree with the literature in saying that. So what is the architecture here? In every phase of the 12 phases of the dodecahedron, which is the dual geometry of the icosahedron, every vertex in the icosahedron becomes a face, a pentagon, in the dodecahedron. And we use that geometry to establish, you see here, functional differentiation of society. So each one of the faces, each color will be here, economy, politics, law. And then we introduce something that is prohibited in Luhmann's theory, which is people. People are not part of the system. They are part of the environment. Remember that we are talking about closed systems. You don't talk about the systems and the parts, like the traditional description of a system where the parts are more than the total. You know, like you focus on the parts of the system, the components of the system. In Luhmann's systems theory, you focus on the system itself and the environment. So it's two different types of concepts of a system. System, environment. So at the beginning, we said that only communication communicates. In other words, people do not communicate. Why? Because they are not part of the system. They are part of the environment. So that's why when we see this slide and we say, well, how come you are talking about Luhmann and all of a sudden you talk about the actor that is people and interaction? How's that? Well, that's what the technology does, because Luhmann is useful to us to diagnose society, but not to intervene society. Why? Because it's a macro system theory. It doesn't go to the micro level where the actor and the interactions takes place. So that's why we have to take Luhmann's theory, which we've discussed briefly, and develop a system using a different geometry. Why? Because the icosahedron isn't enough. So we have to go to the Archimedean solids and then to the Catalan solids and develop through the years. This is not something that happened overnight. We develop a model that you can see what we call here the flowers. These are the same 12 systems, but now they have 10 pentagons, which are the subsystems. So now this geometry, which is very sophisticated, but at the same time very symmetric, because it's based on the icosahedron, which has perfect symmetry. Then we are able here to have a solid with which allows us to represent society not only with the 12 systems by Luhmann, but with 120 subsystems, considering 10 subsystems per system. And this is the model we use now to study society. Again, all this is new. Nothing of this exists in the literature. We are, again, we've been very careful because it's part of a patent that is being developed. And only in this conference, we've published for the very first time something, not the details, of course, but the idea, knowing that, we didn't expect much attention for obvious reasons. We are talking about social capital. So far, what I said here is social systems. Social capitals enters the game once we have here the model design. Because remember, we are developing a tool to study society, governance. So we need to talk about social cohesion, social capital. But first, we have to develop the model, the geometric model, the mathematical model that will allow us to discuss these subjects, which is not you don't see this in discussions in social capital. I don't know if you attended the opening conference. Did you? The one that I think Volker is her name. Did you?
Yeah. I mean, it was what, 3 a.m. for us, so
Yes,
I may have
yes,
been a little tired, but yes, I attended that.
yes. Okay, I think it was to me very interesting because I study the subject area social capital since many years, and it was, I think, an excellent summary of what is the state of the art, which
Hmm.
hasn't changed for the last 20 years, in my opinion.
Yep.
It's basically the same thing. If you read a paper from 2000 and reading a paper from 2020, there are small areas. I'll give you one example just to tell you the type of improvement, which is, in the scientific world, it's important, but it's not, in my opinion, significant. For example, if you see the slides from that opening conference, and when she starts talking about social capital, the very first reference she uses is George Simmel. I was extremely happy to see that because that's uncommon. It's not very common to see when they talk about social capital to cite George Simmel, 1908, as the very first one, a significant one. Why? Because he studied what is called the triads. How the diet change when you add an additional person, and now you have three people interacting. And that's really the basic concept underlying social capital, because you build all the social networks based on that triads. The rest is a dimension,
Yep.
but the discussion starts there. And when you mention Simmel first, and not what is usually mentioned as the founders of this area, to me gave me a very good message of the way the information was going to be presented, and it did. I think it's an excellent conference that shows that not many things have changed. And I said I was going to give you an example, and it is that when Simmel developed the analysis of the triads or triads, he talked about what is called the tertius gaudens and the mediator. So he says when you have two people and another one is added, now you have three, there is all going to be two roles. The role of the person that acts as a mediator or the role of the person that benefits from the other two. That's Simmel's theory. 10 years ago or 8 years ago, David Otzfeld, in his PhD thesis, modified the theory, added an element very useful today in innovation processes, which is, he termed it tertius jungens. He used also a Latin word. Simmel used tertius gaudens. Otzfeld used tertius jungens, signifying the third who unites. So now you have a modified theory where you have the third who benefits, the mediator, and now the third who unites. So things like that, which I'm not saying they are not very important, they are, but this is the type of changes that we've seen through the years. So when you present a model like the one we are presenting, is something 100% disruptive. You don't see in all the presentations in the conference, and there were, I think, dozens of presentations, tens of presentations, many conferences, none of them go to the mathematical aspect or modeling aspect of social capital, which I think is time to start thinking about that. Why? Because otherwise, you don't get to analyze society in a real, powerful, significant way. I'm not saying that we have the answer to all the problems, but it's an attempt to bring a new way of thinking about social capital.
Yep.
It's just that, an attempt. It's very solid from the theoretical point of view because we talk about three levels: the optimization level, which is the strategic level, the tactical level, and the operational level, where social capital usually is discussed, at the operational level. That's where all the conversations takes place because that's where the networks are created, at the operational and the tactical level. That's where Simmel's theory comes into play. And that's where the literature is 99.9%. You don't have literature at the optimization or macro systemic level. And we find it absolutely necessary to introduce gradual social change in society. And that's what we do here. I'm not, stopping here for any longer than just showing that we work with, technology that's being incorporated into the model, very well known in the literature, the Leontiev matrix, the Bogardus matrix, and we introduce a new concept, which is not in the literature, which is the resonant social capital. Because Luhmann never talked about systemic social cohesion. He talked about social trust. He talked about cohesion related to trust, systemic trust. That's Luhmann, systemic trust. We talk about systemic social cohesion. What you see in the literature is interpersonal social cohesion. And when you talk about social capital in the literature, today literatures, the opening conference for that we just talked about, all that is interpersonal social cohesion. She talks, and the literature talks about institutions. That's only part of systemic social cohesion. So this is our model to study society. Once we do the optimization, okay, so that's how we will intervene society. So now we are not in Luhmann's territory anymore. Why? Because now we are totally in the meso and micro levels. We already did what we wanted at the macro level. We did the diagnosis of the society. Now we are at the level where we want to intervene society. And we intervene through a barometer, okay? And we use Latin America as our scenario for what we've done so far. Of course, we would like to do this type of studies in North America. In Canada, we are also, making progress, but most of our use of the technology to analyze society at the macro systemic level, optimization level, is comparing societies in Latin America. For that, you have to measure social cohesion, because at the end of the day, what you want to develop is public policies. But you don't want to develop public policies where you don't have an understanding of society at the macro level. You need to understand what's going on at the systemic level, and then intervene society at the micro level. Today, that's not done that way. You go directly to the micro level where you take some measurements. I attended several of the conferences, several of the sessions, and that's the only thing you see. How you measure at the micro level, or at the most you go to the meso level through the networks. You measure, and then you recommend or act on or design public policy. But you don't have an understanding of the society as a whole when you develop those public policies following the method that I just described. So we use environmental governance as just I would say an instance of the model to say, okay, we not only work in Latin America. Now you are defining geography, but now you are also defining here the political context, because it's not the same to talk about environmental governance in the United States or in Canada or in any country in Latin America. It's a totally different game. So you have to, when you do the macro level analysis, you have to define those areas. So here, just going to the mathematical component of the presentation, and very fast, we established this formula that the systemic social cohesion is inversely proportional to systemic friction, which makes sense intuitively. Okay, the more friction you have, well, you see what happens to the equation. So this is very intuitive, and it allows to bring us other elements from the macrosystemic to the systemic element. So here we do, through this formula, we do the linking between the macro and the microsocial and relational level. We integrate those levels, calculating the cost of social change. When we say social change in the literature, this is very, very well established through Karl Popper, who talked about engineered social change, piecemeal social changes. So we introduce the concept of resonance social capital. Resonance is in the literature. We are combining resonance by Hartmut Rosa, who's the founder of the concept, and with social capital, and we create resonance social capital just to be able to define systemic social cohesion. Without this definition, we cannot talk about this systemic social cohesion. So we say again that this is the product of the social cohesion. Not, you don't add social cohesions. We have empirical evidence that the description is better established through the product of the,
Yep.
again, you could do some exercises and easily see why is more, powerful to define it as the product and not just the addition. Okay, so we combine the formulas and we get to what we say here, the true
Yep.
nature
That's what
of
I
the
was doing in my
problem.
head.
Uh,
Yeah, the bottom one is what I was envisioning is like the cost makes sense as the product of the frictions. Still a little unclear what the value or units or whatever of the actual interpersonal social capital would be, but
okay, okay. So that comes here where we say this is going to be a value between 0 and 1 that we obtain
okay.
from the parameter. I don't go in my presentation, not even in my present. Well, we only had 15 minutes for our presentation, so
Yeah, exactly.
no time to say almost nothing. But I don't go into the details of the Blackos parameter. If you search in the literature, you
Yeah, I'm
do
sure I can
some.
find that.
Yes, I mean the parameters, and the best one I found in the literature is the German version, which is called the social capital radar. I mean, they've done a extremely good work. There are many other barometers for social capital. I would say about I have counted around 10, 12 different versions. But in my opinion, personal opinion, the social capital radar from this foundation from Germany, I think is the one that has come with it. And there is a very, very recent paper from 2026 that, you know, puts you up to date on what these barometers do, and specifically the German one. Well, we have nothing, out of the what is known in the literature, our Blackos barometer. The only thing this is ours. Okay, so the good thing is that we can, use it the way we want to. Maybe it's not as powerful as well, maybe not. It's not as powerful, definitely, as the German barometer, but serves our purpose of calculating interpersonal social cohesion, because it's just a number here. At the end of the day, it's just a number between 0 and 1. Now, if we wanted, we could use the values from the social capital radar and just then plug them in the formula. Okay, where the combinatorial optimization problems comes about when we calculate the friction. So when we go back here, this term here, this comes from Blackos. This comes from, again, another easy calculation, technological friction. I mean, in the literature, you find 10 different ways of calculating technological friction. We have our own way, but it's nothing, magic here. It's all very well. And again, you at the end of the day come up with a number. That number will modify the social, the systemic friction. So at the end of the day, the difficult part in the formula that takes us back to the Platonic solids, the icosahedron, and to the model that we use, that we described before here.
Hmm.
This model, again, to solve this problem, which is 120 factorial, you have to solve this equation. This equation was formulated by Koopmans, who was a Nobel Prize in 1975 for the quadratic assignment problem. That's the formulation. I'm not going to go in any details here. Again, you
Hmm.
can easily see in the literature. You do a Google search, and it's a problem that's being used in engineering
Yeah.
widely. Electrical
Uh,
engineering, mechanical engineering is very, very popular. The
yep.
formula, so you've heard about that, definitely, eh?
I haven't heard, I didn't recognize it by that name, but I've heard of that kind of pathing or optimization problem before. I just didn't know what the name of it was.
Okay, so Koopmans, Nobel Prize in 1975, developed this with Beckman in 1957. And of course, once developed the formulation, now comes, okay, now how are you going to solve it? So you could solve it for 6 factorial, 4 factorial easily with Excel. Once you get to 15, 16 factorial, maybe still with Excel, but you have to be very, very good at programming in Excel. Then you have to jump to evolutionary algorithms or find an exact solution, but you won't go further at 20 factorial. So for us, it's not good enough. We need to solve 120 factorial. So here is the logic of the GATS algorithm, genetic algorithm taboo search. Okay. This is how we do the search space.
Yep.
Okay. Again, I'm not going into details here, but maybe you are more familiarized with this here. The important thing is that we are now able to solve to answer two important research questions. How many optimal permutation sets? Permutation sets. Why? Because we are solving the dynamic version of the QAP that was developed in 1986. Kuhlman developed the static version in 1957, and the dynamic version was developed in 1986. So in other words, the problem is now you don't want the optimum permutation today, but let's say in the following 4 years. So, but every time you change permutation, every time you modify society, because you introduce changes, because you are introducing social change, there is a configuration cost. I mean, you don't change society at zero cost. There is a cost. No, we are not talking here about money. We are talking here about what it means for society to change. Okay, we are talking here about entropy. I'm
Yep.
not getting into that part, but in the literature again, there is something called the social entropy theory. That theory is not what we use here, but what I try to say is that we are not the only one developing a social entropy theory. It is in the literature, is part of what we call socio-cybernetics. So this is a socio-cybernetic model in the sense that we are working with social entropy, and what we are doing is minimizing the total cost of change, minimizing the entropy in the system every time you produce social changes. But you are producing social change we do it from T0 to T4 in a 5-period time. So that's why you get a permutation set. Now, you have to determine how many times that permutation change, because there is a reconfiguration cost. So in the literature, again, if you just Google Rosenblatt 1986, this is a dynamic version. Dynamic is called the DFLP, dynamic plant, because this comes from the manufacturing world. Dynamic plant or dynamic facility layout problem. Dynamic facility layout problem. In 1986, after the problem was formulated, Rosenblatt solved it with dynamic programming. He found the exact solution through dynamic programming. And this is the benchmark. As you see, flows between period 1 and period 2, between machine 1 and machine 2, machine 1 and machine 3, machine 1
Yep.
and
Yep.
so forth. Okay? Here is the shifting costs, because if you are going to change permutations, you have to pay this price. Okay, here it could be any units, okay, dollars, but not necessarily dollars. And here is the distance matrix that you find here, the distance matrix, because what the decision variable is a permutation. You are locating facilities in a place that is at a certain distance from the other places. So where you
Yep.
say a 6 factorial problem, what you are saying is that between location 1 and 2, you have 1 meter or 2 meters or 3 meters. And in this case, as you can see here, the matrix uh, uh, has this characteristic. So for us, this matrix is given by the topology of the icosahedron or the more advanced model. So it's fixed by the geometry, the topology. So the only thing we need is to find the flows. And here is where the resonant social capital comes about, because we are talking about measuring the flow of trust, of social capital. Again, I'm not getting into that because of time restrictions, but that's here you have material flow, we have social capital flow, trust flow. Now the result is again a permutation. This is the solution. Like if you ask internet what is the solution for the Rosenblatt 1986 instance of the DFLP, it will tell you 71,187. That's the solution. Okay, so that's the cost, the optimal cost. If in period 1 you use this layout, period 2 you don't change the layout, period 3 you see here you interchange these facilities, here another change, here another change. So we say GATS didn't just find a solution, it found the global optimum, solving the 5-period dynamic challenge with precise institutional configurations. And I think we are the only one in the literature. I cannot guarantee this because if there are others, they are also protected by patents. We not only tell you the optimal solution and the optimal layout, we tell you all the permutation sets that make that optimal solution. So even though it is 6 factorial or 20 or 30 factorial, we'll tell you, okay, here is your cost, but here is the changes that society has to go through in order to introduce the changes you want for that society, okay, the social changes. But we add flexibility because we say maybe you don't want to change the economy or the justice system in the structure. Maybe you want to start changing other systems. So through the solution by GATS, we offer this flexibility. We don't give a unique permutation set, which is what I think all the other evolutionary algorithms do. We do an exhaustive search in the space in such a way that the algorithm stops when it has found all the permutation sets. Today, there are some solutions that even though there is not exact solution, for 6 factorial, for example, there is. So you can easily prove that is the correct answer because all the NP-hard problems have the property that they are very difficult to solve, but very easy to confirm. Any of these you could confirm easily. Just going back to this here and trying your permutation. So all NP-hard problems have the same characteristic. Extremely difficult problems to solve, combinatorial optimization problems, extremely easy polynomial time to check the solution is correct. Okay, so all these can be checked to be correct. So what are our conclusions? Well, we go from the macro level to the micro level with Blackos, the barometer. We have an algorithm to redefine society. We do piecemeal social engineering, which is a term from Karl Popper, 1957. We believe in the citizen state, which is a concept we work with, saying that it doesn't make sense to do public policies if you don't consider the citizen at the basic level of your process. So doing public policy from top down to us doesn't make sense. Has to be bottom up, but with the condition that you are able to analyze the macro systemic level. You must be able to analyze society. So when you do from bottom up, you not only study what you typically study in the social capital literature up to the micro and meso level. We take it to the macro systemic level And the only way to do it, and again, maybe I'm exaggerating on this statement, but I haven't found any other way different than Luhmann's social system theory to do this. Okay, so we've gone through my presentation that I would have, you know, I didn't have time to do it in our
Yeah.
conference with the
You had to
15
compress this
minutes.
into 15 minutes yesterday.
And really, for me, this was an experiment. I said, okay, I invite, obviously nobody else except you came. But again, that's a good result from the experiment. I'm proving what I already knew, that this is something very strange for people to talk about. People in the social capital world, social cohesion world, to talk about these concepts about macro systemic level. Now, with your permission, because you are the only person here and I'm recording this presentation, I'm going to send this to the organizers of the conference, to Tristan, who is my friend. I met him when he came to Ottawa in one of his visits. I think he's an extraordinary guy, and I think he's been doing an excellent job through this International Social Capital Association. So I'm going to give this to him, and so he can consider what we've presented here today. He doesn't have this level of details of what we are doing, and I was hoping to present it in the conference, but obviously I didn't have the opportunity. No?
Hmm.
So what do you think, Ian?
Oh yeah, feel free to share with Tristan whatever you like from this. I know you were recording it. I would love to look back at this recording or this presentation at some point.
Perfect.
Um,
I will send it to you. You give me your email
yep.
or WhatsApp. I usually communicate through WhatsApp. I think it's very useful. You give it to me, and I'll send you this or any other information you need if you want to get into, more literature in the area. I'm 100% available. We are interested in meeting people with your profile, with your experience, with your background.
Hmm.
So, if they are interested, they could join others that are doing exactly this, which I think is very innovative, okay, and to us very appealing.
Yeah, I think to me, the irony is I think I understand the basics of the math, the geometry, the optimization problem that you're trying to solve. I think where I'm missing is Blockhouse and Lumen and like the background that goes into why you have 12, why you have 10 subsystems.
Okay.
What are those connections? It's the irony is it's the social background that I am lacking here to
Yes.
see the value of these connections. But that's not for you to solve in 5 minutes. That's for me to go back and look at these 30-year-old texts and literature and see what the concepts and the theory is that you're trying to put a mathematical value onto.
Yeah.
So
I,
that's
I
my homework. But
I can tell you that this is a fascinating area. Fascinating. I mean, now you have to be ready to read complex literature, especially in Lumen. Blackos is something extremely easy to understand. Okay, Lumen is a different story. But if you get to read a little bit, you'll find it fascinating. Even the life from Niklas Luhmann, his life is something so interesting. When he started at university, and this is something quoted everywhere in the literature, what I'm about to say, he started teaching at Bielefeld University in Germany, and it is normal procedure to ask the professor that is starting, okay, what is the what are your plans? What are you going to do? What are you trying to accomplish as a researcher? And he said, my project is to model society, just to say very briefly. to develop a theory of society. Duration 30 years. Resources, I need a secretary. So that's it. It took him 28 years before he published his 1984 magnum opus. And today, what is been happening is that every year he's more and more and more recognized, and more literature being translated. And I think it's going to happen more and more and more, because as society becomes more and more complex, because that's at the end what he's doing. He is considering society's complexity by saying that you can only model society as a communication system. So
Hmm.
his theories, which is not only theory of society, but social system theory, social theory in general, I think will become more and more and more valid as time goes by. That's my prediction. But again, just take a look at a couple of his papers. Don't get discouraged if you don't understand. I started understanding him after reading quite a bit. I said, okay, now I'm starting to understand. Because,
Yep.
Ian, the problem is that terminology, the concepts, they are, they change. He changes everything. So it's as if you have to re-educate yourself in many concepts from sociology. So not easy at all.
All right. So
Uh,
no cliff notes for me, huh?
so you are giving me, you send me a message here.
Yeah, I
Okay.
sent you my email, so you can
Yeah.
send me whatever.
Okay.
Um,
Okay. I'm going to,
and if you can think of specific ways that can be helpful, obviously, please let me know. I'll do what I can. I've got a day job and other hobbies and things, obviously, but
yes.
took a day, couple days off work to participate here because I'm really interested in this stuff, and I feel like you, there's opportunities to model a lot more than what is being modeled. So that's kind of my interest, and so I'm glad we've connected.
Yes. And again, once you meet other people that are working in this area, you'll find it more fascinating, because you see really that it has many possibilities to do real things. Although the theory is so complex, although the theory is so abstract, we as mathematicians, we see more value on that, because we understand that the more complex, the more powerful it is. And that gives us, well, at least me, more motivation to continue in researching, because of the practical applications. I come from Venezuela, Latin America, and I really want to bring solutions. I live in Canada and I work in Canada, but come from Venezuela, so my
Hmm.
ties are with Latin America, with Venezuela. And I find it fascinating when I'm able to compare Argentina with Venezuela, the current situation in Venezuela that very well known. How can we make progress from the situation of being, for so long falling behind? Now I have a practical tool when I'm not doing just pure science, but using science, using technology for something useful, even useful for my people. And I find that, very rewarding.
Hmm.
Well,
Yeah,
I
we could talk for
appreciate,
another half hour, I'm sure. But
yeah,
we don't really have time.
no, we
There's
don't
other
have
sessions
time,
about to start.
but I really appreciate your being with me here, and recording this, because again I'm going to share it with Tristan and any other people that I find could benefit from this conversation.
Yeah, of course. I'm sorry I was the only one.
No, it's okay. I'm very happy to spend the time the way we've done it. So any other comment or before we close the meeting?
Nothing I can't email you about once I get your contact information. You've got my email, so we can connect afterwards.
I will. Thank you very
Great. Thank
much.
you so
Have
much,
a
Jose.
nice day.
You too.